magnetization, which is the sum of the magnetic belonging to the okay? If you have a number of estimates belonging to the more than the nucleus of the so in this situation you have a tiny net magnetization. What is net magnetization? Net magnetization is sum of the magnetic sum of the new or magnetic moment. It's called net magnetization.
It means that
Sigma mu. What is sigma?
Summation.
Summation of mu equals m is called magnetization or net magnetization. Then we are studying out the MR scanner. We don't have any magnetization because the summation of mu is 0. But then we are exposing to the external magnetic field. The nucleus would have to this situation or energy states has been obviously down. But if the number of nucleus aligning to the magnetic or B0 is more than the number of nucleus opposing to the B0, in this situation we have a tiny some magnetization which is very small, but anyway we find magnetic poles. We became magnetized. In this situation we became magnetized. Did you understand? Yeah? Yeah?
No.
I have to explain more. How many situations, how many states we have after exposing to the external magnetic field? I mean
Opposite.
Please, what's
I cannot hear you.
You can't hear me?
Yeah.
You can't hear me? Oh, sit here.
Excuse me. There is a mic. There is a mic.
What happened?
we get
Then
magnetized.
we are
Magnetize.
exposing to an external.
Magnetic field.
Some are
Nice.
allied. When the number of allied is more than others, then we are magnetized.
Became magnetized. In this situation, we have a small magnetization vector, which is called M. Do you know anything about Faraday law?
Yes.
Faraday law. Can you remember
Yes.
अच्छा Faraday's law.
Faraday law?
Oh yeah.
Yes. When a magnetic field passes through a substance,
Okay.
It will.
current produces.
Okay.
Go.
If we have an oscillating or rotating magnetic field or magnetization, M, magnetization, this M can induce a current in the loop. This is a
Faraday's law.
No. Okay. In this situation, for the first step, we could produce M. We could produce produce through applying the electromagnetic field. Okay? Without applying magnetic field, we don't have any magnetization. But in this situation, after applying magnetic field, we could produce M. If we have it oscillating or rotating or M with the property of in this situation, we could induce current in M. I have a question. What do you think? Do you think after producing this magnetization, can we have any current in the loop?
No,
Why?
because the magnetic field is constant.
The produced magnetic field in this situation is constant. You can't have any current in a
She's not been there.
what we should do in this situation? We should try to produce
We can,
an alternating and oscillating
Yes.
how can we
We can move the patient,
Or,
move?
move the patient.
No, move the
magnetic field.
M, not magnetic. Magnetic is a constant direction of the tangent. Okay? In this situation, to produce an oscillating or rotating M, we have to move or rotate M. The magnetization, the produced magnetization is in the direction of Z. Okay, in the direction of Z as a whole.
Yes.
But in this situation, we want to have an oscillating M. This M is constant, can't produce current interval. To produce this magnetization of interest, there is a special trick. Don't ask me about the underlying mechanism of it. This is very complicated. I have to explain about lots of formula and physical phenomena. Not to just it's enough for you to know how can we produce this oscillating magnetization. What is the tricky method to induce
When we
or
change the
produce this oscillating magnetization? Do you know anything about it?
yes,
Can you tell me how we can produce the oscillating magnetization of the interest?
when we change the direction of the magnetic field,
Yes.
like
Not the magnetic.
Yes,
Magnetic field is constant
no,
in the direction of Z.
when the
Just change
M.
the
M,
M.
yes, first of all the
Magnetization.
yes, the magnetic field is perpendicular to the patient. When it is parallel to the patient, then there is no magnetic field, so it is changing. So when
If we want to change the magnetization, produce magnetization, we apply the radio frequency radiation perpendicular to the BC. In the X-Y plane, as I explained about the X-Y plane. Okay, you know what is X-Y plane. Okay, if we apply radio frequency RF, do you know anything about RF radio frequency radiation? Radio frequency radiation, RF radio frequency radiation, RF.
Sorry, because
What we have in radio.
yes.
Through RF, we can send and receive the wave
Yeah, synchronize the wave.
Okay, using the radio
It's like when it is perpendicular from radio frequency we will pass
or
the
radio frequency
so magnetic field change.
radiation. If we apply physically, if we apply RF radiation perpendicular to the B0, we can change or we can rotate the M to the XY. At the first step, we have reduced magnetization, which is constant, and to the direction of B0 or in the direction of Z. But after applying RF in the direction of XY plane, X or Y, there is no difference between them. After applying this RF, a oscillating magnetization is produced because the direction of M is changing.
Change.
You know,
Then the magnetic field will not change. Then the magnetic field will not change if we change the M.
yes,
The magnetic.
we can rotate it
Okay.
from the Z direction to the XY plane. Unit
But the
XY plane.
yeah, but magnetic field is constant. Here also constant.
Magnetic field is completely constant.
Okay.
You
We
are
just
speaking about
rotate it.
M. Magnetic field is completely constant. We are speaking about the E. M. Magnetization. Produce magnetization. Which is summation of U. We are speaking about object, not external. We are speaking about the spin, nucleus, magnetic property of the nucleus. We are speaking about the magnetic moment. We are speaking about the summation of magnetic moment, which is magnetization. Okay? We are speaking about the magnetic property of object itself. We are not speaking about the external magnetism. But we have an interaction between magnetic property of object and the externally applied magnetic field. In this situation, as I told you, we can produce a constant magnetization. This constant magnetization can produce current in a loop. Producing current in a loop is signal. Okay? Signal means producing voltage or current in a loop. Okay? This is the meaning of signal. To produce a signal, you need to have an oscillating magnetization. How can we use this oscillating magnetization? There is a tricky method to achieve this aim. What is it?
Radio.
Applying
Veena.
M start to
Rotate.
change, start to rotate from Z to X.
Extra.
This phenomenon can produce signal in a current, produce current or signal. This is a signal. This is a signal. You can we can use the signal to make but you can look at that and using the contrast of the image to the diagnosis for diagnosis, pathology, lesion, disease. To have such image, we need to produce signal in a loop. And we need to have an oscillating M. We need to produce M. We need to have constant magnetic. We are going backward. are standing out there, this kind of thing, we don't have any magnetization. So the strategy behind the MRI machine is to use magnetization for the first level and then produce oscillating magnetization at the next level. This oscillating magnetization can produce current or voltage in L. This is a Faraday law, you know. But I have to explain more about another phenomenon in air. I told you after applying external magnetic field, we have two states. Spin up or spin up, down. Okay, spin up or spin up. You are thinking of the situation as each spin is completely oriented line with the visible or completely opposed to the visible. Okay, like this or this, but it's not right because the fact is that this is hydrogen nucleus, this is magnetic nucleus, okay? This is V0. Each nucleus is precessing about the magnetic, not completely aligned in the direction or against the direction of the sun. Each nucleus is precessing about the visible. It's called precision phenomenon. We call it precision of spins or precision of magnetic moment, which is a vector quantity around the visible. Not like this situation was shown in this picture, completely aligned or completely opposed to the visible. No, it's not the fact. It's a simple picture. The fact is that each nucleus or each moon is processing about the visible, like this.
It's 360 moment,
Yes.
circulation.
Circulation. Yes. This is a circular motion around the visible. Circular motion around the visible. In this case, we have to define frequency, and frequency. Do you know what is frequency?
Yes.
In this situation, one may ask, what is the frequency of precision? What is the frequency of precision?
Number of turn in 1 second.
Yes, number of rotation in 1
1
second
second.
is very important. In this situation, the frequency or number of rotation in 1 second is very important factor because each nucleus has its own
Frequency.
precision frequency. Hydrogen has its own precision frequency. Carbon has its own precision frequency. Fellow, these are nucleus having a spin.
Frequency
This
depend on
nucleus has a spin.
frequency depend on which things?
Frequency depends on two parameters. The main parameter is the strength of magnetism. The strength of external magnetism, which each nucleus is highly related. Okay? For example, if you have 1.5 Tesla V0, or we have 3 Tesla B0.
Yes.
In the second one,
More
the
magnetic.
precision of frequency is
More.
more. So the value of precision of frequency depends on the strength of external amplification, which is very important. And the other constant parameter that depends on the size, mass, and other parameters of the particle, which is called gyromagnetic ratio. Let me show you this formula. This is a very, very important formula in MRI. F, which is precision of frequency, depends on gyromagnetic ratio and the strength of external magnetism. F equals gyromagnetic ratio multiplied by Z. Two important parameters. Contributes to the precision of frequency. The precision frequency is very important because each nucleus, each nuclei, for example hydrogen, carbon, or fluoride, has its own precision frequency. If hydrogen is placed within an external magnetic field, has its own precision frequency because this nucleus has its own gyromagnetic ratio. If we have the constant B0, for example, our machine has B0 equal 1.5 Tesla or 2 Tesla. This is the constant parameter for all nucleus exposed to the external magnetic field. What is different between these two parameters? Gyromagnetic ratio. Carbon has its own gyromagnetic ratio, fluorine has its own gyromagnetic ratio, fluorine has its own gyromagnetic ratio. All of these nucleus exist within our body. What these have different precision of frequency based on their different gyromagnetic ratio. These have different size, different mass, so ultimately have different gyromagnetic ratio.
We need high precision frequency or low precision frequency in MRI.
The best frequencies in MRI, currently we are using 3 Tesla MRI.
3 Tesla.
3 Tesla MRI, so you can multiply 3 Tesla by the gyromagnetic ratio of, for example, carbon, hydrogen. Definitely hydrogen. We are using hydrogen chemical MRI. If we have gyromagnetic ratio of hydrogen multiplied by B0, which is 3 Tesla, we can have the final value for the precision of frequency. Precision of frequency is very important in MRI. I will tell you what this parameter is so important. So I have a question. Can you say all of the hydrogen nucleus in constant externally magnetic field have constant value for precision or have the same value for precision frequency?
Yes, yes.
So I know
There are
It depends
isotopes.
on-
There are isotopes. Different isotopes of.
isotope.
No, it depends on the strength of magnetic field.
You have constant.
Say with
You
constant.
said that.
We have constant.
Yes. Field is
For
also
example,
constant.
3 Tesla or 1.5 Tesla.
Yes. Field is also constant and the atom is also constant.
Then there
So
will be
yes.
same frequency.
we have two important parameters for determining the precision frequency. Okay? What are these two parameters?
Gyromagnetic field and
Gyromagnetic
gyration.
ratio.
B0.
Magnetic.
Zero.
These are constant for the machine. Gyromagnetic ratio constant for the specific
Specific
types
atom.
of the metals.
Yes.
So we can say all of hydrogen within our body have the same precision frequency.
Both are constant.
Based on this formula, it's true.
Yes.
Based on this
Yes.
formula, I told you it's true.
Yes.
But
It's one
experimentally,
different
it's not true.
different and one different.
We have a phenomenon called chemical shift.
Isotopic and
Ma'am, but we
Where are
have
your friends? Get away. Lazy.
just pure words.
ma'am, the gyromagnetic ratio is because
Let me choose the formula. We expect to have the same frequency for all hydrogen bond. But experimentally it's not true. We have a resemblance here.
Chemical shift.
As I told you, the precision of frequency depends on the strength of magnetic field. We expect to have the completely homogeneous magnetic field within our body or within the interior volume of the bore magnets. But it's not true. We have inhomogeneities in the volume of bore magnets. It's too hard to produce completely homogeneous magnetic field within the bore magnets. It's very hard. And also there are another reasons based on the structure of the atoms, structure of the electrons that make the magnetic field unhomogeneous. We have numbers of electrons circulating around the nucleus. These electrons have its own magnetic field. You know. The magnetic fields of these electrons can affect on the magnetic field around the nucleus. We have magnetic field around the electrons, we have magnetic field around the nucleus. We are capturing signal from the magnetic field around the nucleus. We know, but the magnetic field around the electrons can affect on the magnetic field around the nucleus. Hydrogen nucleus may be at different chemical structures. We have different chemical structures within our body. We have fluid, different fluid. We have solid state material. We have bulk, pure water. We have soluble water. We have different molecules within our body containing hydrogen nucleus. Okay. So hydrogen is placed at different chemical structures, different chemical states, depends on where they reside. Okay, they reside. So the effect of magnetic field of electron on the magnetic field of nucleus is different at different chemical structure within our body. So I told you two important reasons for magnetic field to be different at different locations of the body of energy within the bore magnets.
Electrons.
electronic magnetic medium.
Electrons, the second,
Different conjugative
Medium.
power.
due to instrumental reasons. Instrumental is too hard to produce homogeneous magnetic field within the hollow of motion. It's too hard. So we don't have we don't have homogeneous magnetic
सीधा
field
movement
within the volume of
Field align करना था.
अच्छा अच्छा.
the precision of frequency depends on two parameters.
German.
Gyromagnetic ratio, external
Lead
magnetic field. Externally applied magnetic field may be different at different locations. So different hydrogen may experience different magnetic field. So the final precision of frequency may be different for different.
Less of it.
This phenomenon is called chemical shift. We use it. What I'm saying is very, very important because this phenomenon formed the basic of an advanced MRI called magnetic resonance spectroscopy. Using this advanced technique, we characterize the properties of a chemical compound based on the precision of reference. We know in a specific chemical compound the precision of frequency, the value of precision of frequency. If we know the value of precision of frequency for a specific compound, after measuring the signal and understanding the value of precision of frequency, we can characterize the structures of the molecules. This is the basis of this is the principal basis of magnetic resonance spectroscopy. We use of this property in magnetic resonance spectroscopy. Different precision of frequency at different molecules. So we can characterize the chemical compound, characterize the structural properties of the specific chemical compound. In some cases, to discriminate between malignant or benign tumor, we use magnetic resonance spectroscopy. Because in these two situations, the precision of frequencies of the hydrogen may be different. Because in the case of malignancy or in the benign situation, the structure and composition of the tumor is different. So based on this phenomenon, we can characterize whether this tumor is benign or malignant. It's very important. Currently, we can use magnetic resonance spectroscopy method to identify the nature of tumor, which is whether the tumor is benign or the tumor is malignant.
Ma'am, you said that precision frequency for same nucleus, like hydrogen, different hydrogen we have, is practically not same. So how we can identify, because we have millions of hydrogen now.
Yes.
So we have different, practically we have different precision frequency. So how we can identify by this process you said?
In a specific chemical structures, the all hydrogens have nearly the liquid situation, all of the hydrogen residing on the different locations of these molecules have the same frequency. But in case of other chemical compounds, all of the hydrogen residing on different locations of these molecules have the same frequency.
Because you said that the field is not constant for every hydrogen because of the two reasons, electrons and the instrumental. So how we can identify? Because hydrogen, we have hydrogen atom at different parts of our body. Before reaching that hydrogen, the field experience many other fields like different other atoms. The field of different other atoms. So how the precision frequency of all these hydrogen are same?
No. Which of you understood this phenomenon completely? Can I explain it for your friend? You can? Explain
You said that this process is used to identify the precision frequency of different molecules. So we can identify different molecules, different atoms.
different molecules, hydrogen,
Yes. But you said that
in different molecules.
yes.
Okay, hydrogen, nucleus have their own precision of frequency. If we can capture the signal and precision of frequency, we can identify the precision of frequency after capturing the signal. Okay?
I'm saying that
We
like
can
this
identify
body,
different molecules.
like he's in the MRI machine. I'm passing the magnetic field from here, and he has hydrogen here and here, different parts of his body. The hydrogen here experiences the magnetic field first, then the hydrogen here experience magnetic field after. The hydrogen here experience the magnetic field is affected because it experiences many other atoms like carbons. Carbon has a magnetic field there. Electrons has magnetic fields. So how it is? You also.
We are capturing signal just from the hydrogen. Okay?
Yes. So, but it is crossing the body, so it experiences the magnetic field of other atoms. So you already said that the field is affected, not homogeneous because of electrons. So how we can identify different molecules?
The effects of different magnetic field,
Yes.
the effect of unhomogeneous magnetic field is very low compared to the effect of electron storage of electrons circulating around the body. I told you two important factors are important in creating different precision frequency. Okay. The first item was different magnetic field. The second one depends on I told you depends on the
Instrument.
electron circulating. Okay. We have two parameters. The effect of unhomogeneous magnetic field is very low. The effect of electron is very high. Okay, so we can the situation of electron around the nucleus is specific to each molecules. Okay, it's a specific to each molecules. So we can identify the precision frequency based on, or we can identify the structure of its molecule based on its specific precision frequency. Okay? Did you understand? So the effect of unhomogeneous magnetic is very low.
It means
And we
we
can based on the electron sections. The states of electron around the is very important than the other factor. So we can completely identify the molecules. Then the capture signal from the molecules. We can understand their specific frequency or precision frequency. This is possible. We have a very complicated concept between it, but we can understand the nucleus with what frequency is specific around the magnetic. Okay? So we can identify the molecule. This specific molecule has its own precision of frequency as a general concept. I mean, in the case of hydrogen. Okay? This frequency is generally called Larmor frequency. Larmor frequency. This phenomenon was conceived by Larmor. So we call it Larmor frequency. The final magnetization, you know what is it? Final magnetization, okay, equals to several particles. B0, the strength of B0, gyromagnetic ratio squared, okay, Planck constant squared. This formula is very important. This is another square constant. Temperature. These parameters are really important to create magnetization M0. You know what is M0? The summation of mu. Okay? And the main factor is proton density, the number of proton in a specific volume, in a unit of volume. Proton, we call it proton density. The number of protons, the number of hydrogen nucleus within a unit of volume. It's called proton density. M0 equals to or proportional to proton density. As I told you, we can capture signal from oscillating M. Do you remember?
What is T
We
here?
can capture capture signal from the oscillating M0, M, as I told you. Okay, M0 is proportional to a parameter. It's called proton density. The number of protons in a unit of volume. For example, within our body, we have to different tissue within our body. In one tissue, we have a higher proton density, in another tissue, we have lower proton density. In these situations, we have more M0 for one of these tissues and lower M0 for another. Okay? It's true. Because M0 is proportional to proton density. Can you tell me the strength of induced current in the loop depends on which parameters?
Change in magnetic field.
The difference of magnitude?
Yes, change in magnetic field and distance.
Based on this formula, this doesn't. Look at this formula. As I told you, we have signal in the loop originated from the oscillating energy. Okay. The magnitude of current is proportional to the magnitude of. Look at the screen. The magnitude of induced current is proportional to the magnitude of
Magnetize.
Final magnetization.
Summation.
we are inducing current in the loop
Mu.
based on oscillating M0. So we can say the magnitude of current is proportional to the magnitude of not mu, but the summation of mu. The summation of mu is
Spins up.
the summation of mu is
Spins up.
Angular momentum.
M. The net magnetization.
Sum of magnetization.
A number of state aligned, number of progressive opposite, the summation of mu is called magnetization. This is magnetization we are speaking about. This magnetization is proportional with several factors. Here it's not. But I'm asking you if we have if we induce current in a loop by producing an oscillating I would say the magnitude of current is proportional to the magnitude of
Magnetization.
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 M. Okay. The magnetization is proportional to
Total density.
photon density. Having different photon density can induce different currents in the loop. In the case of having a tissue with lower photon density, we can use a current with lower magnitude. And in the case of having a tissue with higher photon density, higher current with higher magnitude is induced in the current. So if we can capture signal from all of tissues or from both tissues, I told you, we can separate these signals from the other signal and we can understand the photon density of this tissue is lower than the photon density of another tissue. This is the meaning of contrast. After accurate signal, we can make an image based on captured signal.
Then
Okay?
we were just considering the hydrogen atom. Hydrogen.
No, different tissues in within our body may have different photon density. Hydrogen is not uniformly distributed within our body. Based on the type of tissue, we have different distribution with hydrogen. For example, in solid tissues, we have dense hydrogen. In the case of water, pure water, we have not the dense distribution of hydrogen. Okay? In the case of fat or lipid, we have different distribution of hydrogen, which is the meaning of proton density, the number of hydrogen within a unit of volume, which is different in solid, in pure water, in soluble water. Okay?
So this method is just used to detect the number of hydrogen.
Yes.
If there is no difference in hydrogen atom, then we can't see anything.
If there is no difference between them, we can't have contrast on the image. We can't see different tissue, different we can see. Okay? If we can set our imaging so that we capture signal based on proton density, based on set our parameters. We have different parameters in the model. I'm not going to explain or teach this concept. We have a lot of parameters in the model help us to set our imaging based on, for example, proton density, and we call the final image proton density weighted image. In this case, we call it proton density weighted image. In this case, we set our imaging based on a physical property of tissues. In this case, is proton density. We have different physical property of every tissue.
Can we determine the proton density just by seeing the image?
What?
For example, the feature of the image we
Yes,
get.
yes, we are capturing signal based on the feature of different tissues.
Now, for example, I have image, MRI image like this. Can you determine here is the largest proton density, this portion has the lowest proton density image?
Yes. 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 Our aim is to capture signal MRI is to capture the existing differences between different tissues in MRI. We want to make a contrast MRI. We want to see different tissues on MRI differently. This is the final ultimate aim in MRI. But especially in this case, we can see different tissues based on the proton density. If we have different tissues with different proton densities, if we set our imaging based on proton density, we can see these tissues differently on the image. We can say this tissue has lower proton density, this tissue has higher proton density. This tissue must be at the same value of proton density. And now what here appears differently. This tissue may be sick. This may be lesion, not a normal tissue. Because I expect a special guerrilla or color for this tissue based on the value of proton density. I know what is strange level of we can see the contrast using guerrilla, using the value on the image, using some number on the image. So we can understand, we can identify whether this tissue is normal or is a lesion. That is our important. Proton density is important physical feature of tissue, can help us to identify the nature of the tissue based on observed image.
Do you have any image in your brain? MRI.
Hey?
Yeah.
Yeah.
X-ray. No.
X-ray?
I'm asking you.
Okay.
Okay.
I'll explain chemical shift, okay? You know what is chemical shift, it's very important. I'm going to you about T1 and T2. Two other physical properties of tissue, which are very important.
And how we can identify the molecules like by proton density. We can we can identify the defects by proton density, but